Okay, I'm going to go ahead and start, and hopefully some more people try to start coming in. But here's just a few announcements. Our Unit 2 exam is going to be on Wednesday, October 28th. So that's 1 week from today. I put here how you can review. You can review the PowerPoints, the lecture videos, go over the practice problem videos, independent practice problem videos, review guide, which I'm going to post on Friday, the Unit 2 review problems, which I'll post on Friday with the answers, and then attend the review days on Monday and Tuesday of next week. So these are just the different ways you can review. I will go ahead and just give you a brief reminder of where these things are located in case you don't know. So you'll go to the Classworks tab. The easiest way to find everything is to go to here where it says Monday and go to the Unit 2 timeline. And when you click on this, you'll see everything that we've done in Unit 2 as well as the lecture notes video. So you'll see here, you'll just click on this link and you can review that lecture. Here you can see different practice problems videos, so you can see me going over those different practice problems. Here's your independent practice problems that you did an assignment on asynchronous days. And then I went ahead and already explained how we get to the correct answer and what the correct answers are in these videos. So if you've done the independent practice but you're unsure how to get to the correct answer, you can go ahead and review this video and you'll just see me reviewing those problems. And so that is basically for every lesson. So there's 5 lessons. So this is just Unit 1, but there is one for every lesson. And today we're on Lesson 4. Friday we'll do Lesson 5 and then we will be done with Unit 2. And if you already want access to the review guide and the review problems, they are here. But if you are to review them today, just know that we haven't gone over symmetry, which we will do on Friday. So whenever you're going into the review guide and you see symmetry, you may be like, when the heck did we go over this? So we haven't yet, but we will on Friday. So yeah, basically all the links to everything's on here. And if you ever need PowerPoints, that's the one thing that isn't on that Unit 2 timeline. Well, then you would just go to, for example, here you have Unit 2, Lesson 3, and then you'll see this PowerPoints in both Spanish and English as well as the lecture video. If you want PowerPoints before Lesson 3, then you'll just go to here where it says Unit 2, and then you'll also see the lessons that we went over last week and their PowerPoints and lecture video. Okay. Okay. 1 second, I see somebody else. Okay, wonderful. Okay. Oh, and I didn't even have to do that because the link is here. So in order to help you best prepare for this exam, I would get caught up in all Unit 2 assignments. So that includes all the independent practice problems we've done so far. We have done 3 so far. And so I would go ahead and get caught up on those if you are behind. Again, remember that you can do the independent practice problems on Ingenuity, on Google Classroom, or you can do it on paper and then just submit a photo of your work to me through email. Is there any questions about any of these announcements? Any questions? Okay. And so today is Wednesday, October 21st. We do have a due now. This due now is pretty similar to the ones we've done in the past. I'm just asking, how are you doing right now? Just in general. I know it's been a while since I've asked you directly how you're doing, so I just want to check in. And then hopefully I get to respond to you tomorrow. This due now is located in Google Classrooms under the Classroom tab and then under Friday. So I'll give you guys 5 minutes to do that, and then we'll come back, okay? Okay, wonderful. Now that we've done that, we can go ahead and jump into today's lesson. Today's lesson will be pretty brief, but our objectives are students will be able to determine the roles that describe a given function of transformations, and students will be able to determine the image of a figure after a given composition of transformations. A lot of today is actually going to be a review of what we've already done, and then we're just going to be combining that together to understand what compositions of transformations are. So let's hop right in. This is Unit 2, Lesson 4. And again, we are nearing the end. We just have one more lesson until Unit 2. At the end of today's lesson, we should be able to answer the question, what does it mean to compose transformations? So far, we've gone over different types of rigid transformations. Let us remember that rigid transformations, or what is known as isometric transformations, preserve the angle and lengths geometric figures. So we had three different types of rigid transformations: a translation, which is known or referred to as a slide in a plane; a reflection, which is known or referred to as a flip in a plane; and a rotation, which is known or referred to as a turn in a plane. So we've learned about these different types of rigid transformations so far. So I want to do a quick check for understanding, just to make sure we are all caught up and we are not having any difficulty. So I want to ask you, which rigid transformation would map the pre-image to the image ABC, A prime, B prime, C prime? A rotation by 90 degrees, a reflection, a translation to the right, or a translation up? Which of these transformations did we use to go from this pre-image to this image? I see Thomas says B. Does anyone else agree or disagree with Thomas? Gabriel says B. Okay, give me 1 second so that I can mark some of you guys who just got in present. Okay, and you guys are correct. This is an example of a reflection. As we can see, the pre-image was flipped around to create our image. So good job, guys. Okay, so now that we've done that, we are going to go into a composition of transformations. A composition of transformations is a combination of two or more transformations performed in sequence. So what does this mean? Well, it may look like this. Here we have two different types of transformations taking place. And the way that we read these transformations is from right to left. What does that mean? Well, we start with the rightmost transformation first and then the leftmost transformation. So here, first we would conduct a reflection across the M, and then we would do a rotation about the origin E prime, 90 degrees. So these are what compositions of transformations look like. Again, we read them from right to left. So the first thing we would do is a reflection across the M, which would look like that. Then we would do a 90-degree rotation about E prime. Remember that we know that this capital R stands for rotation. This tells us what our origin is, and then we know our angle of rotation. And so after we complete the first transformation, then we are allowed to complete the second transformation. And then at the end, we will arrive at this image. Okay, so that's what a composition of transformations is. The biggest takeaway to remember is that we work from right to left. Okay. So I want to do a quick check for understanding and see if you can tell me which diagram represents this composition. So here we have a composition of a rotation about the origin 180 degrees and then a reflection across the x-axis. So remember, we're working from right to left, so we complete this one first and then this one second. Can you guys give me a guess as to which one of these diagrams represents this composition of transformations? What do you guys think? Which of these represents a composition of transformations? So first we would rotate about the origin 180 degrees, so that's the first thing we do. And then after that, we reflect across the x, the line x. So what do you guys think? Just shoot a guess. We will go over it in a little bit. Thomas says B. Anyone else agree with Thomas? B. Okay. And Thomas is correct. B is the correct answer. So how do we know that? Well, we know that we have this composition of transformations and we start from right to left. Well, we know our pre-image always starts with the image that does not contain the prime notation. So this is our pre-image. So we start here. Well, the first thing we want to do is rotate that pre-image 180 degrees, which we've done right here. And now we have our pre-image. And after we do that, we want to go ahead and reflect across the line X, which we've done here. And we know that we've composed two types of transformations because we start with our pre-image. Then we have one notation represents our image. And then we have two notations that represent that we have two different types of transformations taking place. Okay? So the big takeaway is to always identify where your pre-image is first, then identify what the next step is by identifying the one with one prime notation, and then identifying what the second step is by identifying the one with two prime notations. Okay, but we'll review this right now. So there we have our rotation about the origin, 180 degrees, and then we have our reflection about the x, the line x. Okay. And so here's an example of us going ahead and completing a specific type of composition of transformations, and that is reflections and translations. So here we have a given transformation where we have a reflection across the line M, and then a translation 0 units horizontally and -3 units vertically. So what does this look like? Well, again, we would work from right to left. So we complete our first transformation, which is to reflect the pre-image across the line M. And so there we go. And when we reflect that pre-image across the line M, what we get, or what we can identify, is that the W and X coordinates change orientation, but the only thing that stays the same is the location of Z and Y, the segment Z and Y. So that's just something to know. After we complete that first transformation or reflection across line M, then we can do the next set of transformations, which is to go ahead and move vertically -3, so 3 units down. And so we move 3 units down, and here we have our resulting image after those two transformations. Okay. And then at that point, all of our points have shifted to a different orientation, and nothing remains the same. Okay, so what we did was we went ahead and first reflected across the M. And then after we did that, we did a translation 3 units down on the Y axis, and then we got our resulting image. Okay? And so what's really important in a composition of transformations is to complete the transformations in the order we just discussed, doing the rightmost transformation first and then the leftmost. The reason being is here we see two diagrams that have been both reflected and rotated. The first diagram was first reflected across the line M, and then rotated about the point G prime, negative 90 degrees. Okay. But the second diagram was rotated about the origin G prime, negative 90 degrees, and then reflected across the line M. So as you can see, if we read the composition of translations backwards for some reason, then we would get the wrong resulting image, right? So it's very important that we read from the rightmost transformation to the leftmost transformation. Okay, if not, we're going to end up with two very different looking diagrams or the wrong answer. Okay. Are there any questions? Any questions? So let's look at this diagram and do a quick check for understanding. We want to know which composition of transformations would map LMO to L prime, N prime, N prime, and O prime. So we start with our pre-image, L, M, and O, and we want to know which of these compositions represents the mapping of our pre-image to our resulting image. Remember, we go from the rightmost transformation to the leftmost. So which of these do you think would represent the composition of this diagram? I'll give you guys a second to look at the answer choices and think about it. What do you guys think? Which composition of transformations would map our pre-image, this is our pre-image, to our resulting image? What do you guys think? And so that is the correct answer. The correct answer is C. How do we know it's C? Well, the first thing we do from our pre-image to our image with 1' notation is rotate about this point M 180 degrees. And then after we've done that, well, the next thing to do is to go ahead and reflect that across this line W. And then that gives us our final image after those composition of transformations. Okay? And remember, it is C, not D, because the first thing we need to do is rotate and then reflect. And then D tells us we reflect and then rotate, which would give us a totally different image. So this is the correct answer. Good job. And so, again, transformations can occur in coordinate planes, and rigid transformations in coordinate planes can be mapped using the following rules. We have reviewed these rules so far. We've reviewed reflections, translations, and rotations. But what I want to do is offer you guys a brief reminder of what these mapping rules tell us to do. So, give me 1 second. And I'm just going to review a few of the mapping rules just so you remember what those mapping rules tell us. Okay. So let's look at the mapping rules for reflection. Okay. Our first mapping rule tells us that if we have a rotation about the x-axis, well then we keep the x and y coordinates the same but negate the y. If we have a rotation about the y-axis, well then we take our original coordinates, keep the x and y coordinates where they are but negate the x. If we have a reflection across x equals y, we take our original coordinates and we go ahead and switch the x and y coordinates If we have a rotation about y equals negative x, we take our original coordinates and we go ahead and switch the x and y coordinates and then negate them. Well, what does this look like? Let's say that we start with a coordinate 1 and 2. Well, if I want to reflect the point 1 and 2 across the x-axis, I would keep those coordinates where they are, and then I would go ahead and negate the y, as it tells me to do here. If I wanted to take the original coordinates and do a reflection across the y-axis, again, I would keep the x and y where they are, but then I would negate the x, as it tells me to do here. If I want a reflection over y equals x, I would switch the x and y, because that's what it tells me to do here. And if I have a reflection over y equals negative x, I would switch x and y first, and then I would go ahead and negate them, as it tells me to do here. Okay? Is there any questions still about reflection mapping rules? No? Okay. Now let's look at our translation mapping rules. This is just a review. Remember that translations can be represented two ways. We can have t, what happens to A, what happens to B in our original coordinates, or we can have our mapping rule that looks like this. Right? So those are the different ways we can represent translations. Well, let us say that we want to have a translation 4 and negative 3. Well, this translation function rule would also be written as, we have a positive 4, so we write plus 4. And we have a negative 3, so we subtract 3. So now we would take our original coordinates, which is, again, we're going to use 1 and 2. We would add 4 to x. So 1 plus 4. And then we would subtract 3 from 2. And we would end up with the coordinates 5 and negative 1. Right? So these translation rules tell us what to add or subtract to our original x, or what to add or subtract to our original y. Is there any questions still about translations and their function or mapping rules? No? Okay. Now I'm going to erase this so that I can go ahead and do rotations and just have space to do that. So we have different rotation mapping rules that we've learned about. We have a rotation about the origin 90 degrees, which takes our original coordinates, switches the x and y, and then negates the y. We have our rotation about 180 degrees, which takes our original coordinates, keeps the x and y where they are, but negates them. And then we have a rotation about 270 degrees, which takes our original coordinates, switches the x and y, but negates the x. And so once again, if we were to take this original coordinate and use that mapping rule, well, if we wanted to have a rotation about 90 degrees, we would first switch the x and y coordinates, and then go ahead and negate the x or the y, because it tells me to do that there. We wanted a rotation about 180 degrees. We would keep the x and y coordinates where they are, but negate them both, because it tells me to do so here. And if I wanted a rotation about 270 degrees, again, I would switch the x and y coordinates and then negate the x because it tells me to do that there. The any questions still about rotation rules or rotations in general? Questions? No? Okay. So the big takeaway is that the different mapping rules tell us what to do to our original coordinates. And so if we had multiple different original coordinates that created a specific shape, say a triangle, well then what we wanted to do in order to find that the resulting image after that specific translation would be to complete these mapping rules on every single coordinate. And if we do that mapping rule to every single coordinate, well then we will find out where our image lands after a specific transformation. Okay. These mapping rules tells us what to do with an original x coordinate. So if we were given a specific x coordinate, well these mapping rules tell us how to go ahead and change those x coordinates. So if we have a reflection, specifically a reflection across the x-axis, well then this is how we would alter the original x coordinates. If we have a reflection across the y-axis, well this is how we'd alter those original x coordinates. If we have a reflection across y equals x, well this is how we would alter those original x coordinates. And if we have a reflection over y equals negative x, well this is how we would alter those original x coordinates. So these rules tell us how to map our original x coordinates to our resulting coordinates after a specific reflection. Translations tell us what to add or subtract from our original x and y to represent that translation. So it tells us to take our original coordinates, what to add or subtract to those original coordinates to represent our coordinates after the translation. Our rotations tell us what rotation we've had, about the origin, and how many degrees. So if we have a rotation about the origin, 90 degrees, well then we take our original coordinates and we complete this mapping rule. If we have a rotation about the origin 180 degrees, well we take our original coordinates and complete this mapping rule. If we have a rotation about the origin 270 degrees, well then again we take our original coordinates and complete this mapping rule. So these different rules tell us how to alter our coordinates after those specific transformations. And these we've reviewed already, and you should have been able to go over it in your independent practice problems. Okay. And so here we have an example of transformations in the coordinate plane. And this question is asking us to identify what are the vertices from the final image after applying the composition. And remember, we read this from right to left. So first we have a rotation about the origin 180 degrees, and then a translation -2 on the x and +4 on the y. So what we want to do is take our original pre-image coordinates and then first do complete this mapping rule to those original coordinates, and then after we've done those mapping rules to those original coordinates, we will complete this mapping rule onto those original coordinates. So again, we read from the rightmost to the leftmost. We complete the first type of mapping rule, so we take these original coordinates in the pre-image, do this mapping rule, which tells us to just negate the x and the y coordinates. And then after we've done that, we take these negated x and y coordinates and then complete the transformation rule, which tells us what to add or subtract. And in this case, we subtract 2 from x and add 4 to y. And so what we're doing is we are using our composition to identify which mapping rule to take on first and then which mapping rule to do second. And as a result, we end up with a resulting image located here. And so today we reviewed transformations And we reviewed that transformations can be composed into a sequence of transformations. The order in which transformations are applied is very important, and the rightmost transformation is always applied first. So basically, that's the big takeaway about composing transformations. Okay, the order is very important, and the rightmost transformation always comes first. Is there any questions about any of this? Any questions? Questions? No? So today's glossary terms are composition of transformations, which again is two or more transformations performed in sequence to create a single image. And so this allowed us to answer the question, what does it mean to compose transformations? Well, to compose transformations means to apply a combination of rigid transformations in a specific sequence. The transformations are combined, or a combination of rotation, reflection, and translation done in a specific order that will preserve lengths and angle measures. Okay, so a composition of transformations is basically just a combination of all the rigid transformations we've learned thus far. And as a result of completing those combinations of transformations, we arrive at a resulting image that preserves both length and angle measures. Okay. Any questions? Questions? No? Okay. If there's no other questions, just remember that if you didn't do the do now today, I would go ahead and do that. You do have until tomorrow at the start of class, but I would do that as soon as possible. And then tomorrow is an asynchronous day, so you will be working on Unit 2, Lesson 4, Independent Practice Problems. And remember, you can do this via Ingenuity, Google Classroom, or you can do it on paper and submit a photo to me via email. Is there any questions about any of this? And that is due Friday at the start of class. Any questions? Questions? No? Okay. If there's no other questions, you guys may log off, and thank you for coming today. Bye, guys.